This is the Daily Space for today, Tuesday, June 16th, 2020. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. One of the most remarkable things about astronomy is that we have the ability to understand things we can't touch, measure, or otherwise experience up close. Here from the surface of our pale blue dot, we can observe our universe and say, yes, I know how this formed. We don't know all the details, but our big picture understanding is capable of making remarkable predictions that prove true over and over again. Sometimes, though, our models for how objects work are remarkably vague. Consider the pulsar, these whirling blobs of a special kind of neutron star that appear to rotate tens to hundreds of times a second. And with each rotation, we see two pulses of radio light. First detected by Jocelyn Bell Burnell and her thesis advisor in 1967, these pulses have been described as bright spots or jets associated with the poles of the star's magnetic field, which must not be aligned with the star's rotational axis. The idea is, as the star rotates, the magnetic poles come in and out of view, and it is only when they are pointed generally toward us that we see these pulses. Now, this raises some questions like, why are there bright spots? Well, that part has been a bit of a mystery for many decades. Pulsars are weird objects. They aren't really stars, but instead are the dense cores of former stars that blew off their atmospheres in supernovae explosions, while their cores collapse down so small that only neutrons can get close enough together to exist. They are a kind of dense we can't comprehend. They are 1.5 solar masses resting within the diameter of Manhattan Island dense. They are a tablespoon's worth, weighs 10 million tons dense. They are so dense, physics goes relativistic in a lot of cases. That's how dense they are. Figuring out anything about these objects has been a challenge. But now, one team has found a way to use physics to explain the bright magnetic poles of pulsars. In a paper appearing in Physical Review Letters, researchers describe how the interplay between magnetic and electric fields can drive what might be described as photon-producing lightning. Now, that is one heck of an oversimplification, and this work is rich in details. It is the details in this work that make it so interesting. Here is what they think is happening. The neutron star's massive magnetic field is tearing electrons from the star's surface and accelerating them like a naturally occurring railgun. This acceleration drives the release of gamma ray energy photons that interact with the magnetic field to transform energy to matter, creating pairs of electrons and positrons. Initially, some of these particles are accelerated, leading to further pair production. These newly coalesced particles eventually fill the region and dampen the electric field momentarily, creating an oscillation in the field. And we observe this oscillation as radio waves. According to lead author Alexander Filipov, the process is a lot like lightning. Out of nowhere, you have a powerful discharge, producing a cloud of electrons and positrons, and then, as an afterglow, there are electromagnetic waves. This work takes advantage of modern computing technology. These are exceedingly complex systems, and past attempts to simulate what is going on could only follow a single line of points radiating up from the pole. And that 1D kind of a model can't simulate the electric fields that are so important in this result. In this paper, these researchers, who are part of New York's Flatiron Institute, were able to create a two-dimensional model that cuts a plane through the magnetic pole and thus can follow some of the electric field phenomena. Now, we need to point out the universe is three-dimensional. And this 2D model will be missing things. And we won't know how important those missing unknowns may be until we can do 3D models. Luckily, this is a pretty symmetric kind of system, so the model should be getting the big picture right. And this should be one more phenomena that has gone from a vague explanation to a science-based, kind of detailed explanation. Science advances as our technology advances, both in how we are able to model objects in the universe and in how we are able to observe them. Science also advances thanks to the creativity researchers employ in using both their models and their telescopes. In a new paper in Astronomy and Astrophysics, an international team figured out how they could use the combined observing capabilities of the Atacama Large Millimeter Array and the Very Large Radio Array, the VLA, to observe the outer layers of the nearby massive star Antares. With our eyes and visible light telescopes, we only see the star's photosphere, the layer where light is released into a mostly transparent gas to begin its journey through the universe. ALMA, working in the millimeter and submillimeter wavelengths of light, could see the chromosphere that is above the photosphere. And the Very Large Array, working in even longer radio waves, could map the even more distant wind acceleration zone. This allows us for the first time to see these outer layers that we are used to only seeing surrounding our own nearby sun. This allows amazing comparisons. For instance, while our sun's chromosphere is only 1/200th of its radius at the photosphere, they found Antares' chromosphere extended 2.5 times the star's radius away from the photosphere. They also found that Antares' chromosphere is warm rather than exceedingly hot, coming in at a peak temperature of just 3,500 degrees Celsius, as compared to our sun's 20,000 degrees Celsius temperature. These measurements will help us piece together relationships between stellar rotation rates, sizes, and other facets, and the temperature profiles beyond the star's photospheric surface. It's a start, at least. And for now, it is simply amazing that we can now see the outer layers of other stars. Well, space scientists use a lot of different kinds of data. Image data is one of the best ways we have to study and compare worlds. It is from orbiting satellites that we're learning to see our Earth and a myriad of rocky surfaces as often more similar than different. Intriguingly, one of the most Earth-like geologies we see can be found on a distant moon of Saturn. The large moon Titan has a thick atmosphere, lakes of methane and ethane, and early images by the Huygens probe even spotted what appeared to be river deltas on its surface. Now we learn volcanic craters with complex rims can also be found on Titan. In a new paper appearing in the journal Geophysical Research, PSI's Charles Wood and co-author Johnny Rodberg of BYU used images from the Cassini mission to make this discovery. The craters appear in Titan's north polar region and may be associated with massive lakes. According to Wood, the close association of the proposed volcanic craters with polar lakes is consistent with the volcanic origin through explosive eruptions followed by collapse, as either maars or calderas. The apparent freshness of some craters may mean that volcanism has been relatively recently active on Titan, or even continues today. Now, volcanism doesn't mean there are massive lava flows or any of the magma-related processes we're used to seeing here on Earth, and even on Mars. These eruptions on Titan could be driven by methane, nitrogen, or some other volatile material. We can only hope that the future Dragonfly mission can now plan to one day observe whatever these outbursts may be. Until then, it's cool to see how the science here and the science on Mars and on Titan, all very different worlds, all lines up to create the same kinds of volcanic craters. Now, speaking of planning to observe, if you are in Central Africa, the Middle East, or Southeast Asia, you have an annular eclipse coming up this weekend. Normally, I'd be advising you to plan to hop in your car and drive somewhere to see this natural phenomena. But these are plague times, so please stay home and stay safe. Eclipses aren't that rare, and you'll have another chance. Don't worry. Still, if you have a balcony or yard, it will be worth going outside to take a look. This will be a morning event for most, and you can find the exact times when the moon blocks the sun for your location at timeanddate.com. We'll be providing links on our website, dailyspace.org. And as always, do not look directly at the sun. We'll also post links on how you can safely project the sun using a standard household item like a colander. If you're not in the right place in the world to watch, or if you can't safely go outside, don't worry, we've got you. We'll be providing live streams from community members Ambius and Jillian, who are in Israel and Pakistan. If you want to join the stream and have a prime eclipse viewing spot, please let us know on the CosmoQuest Discord. All are welcome. Tomorrow we will be back with Rocket Wednesday. But for now, this is all the science we've got. And what a lot of science it was. Thanks for being here. This has been The Daily Space.